Hi, and welcome back to XAML for Windows 10. We're talking about layout. We were just talking about some of the fundamentals of layout controls. Now we're going to talk about building your own layout control. Pretty exciting. Darren, welcome back.
Welcome back, Jerry.
We've got the whole away team here.
Yes.
And you are, just as a reminder,
Darren May, president and co-founder of Crank211. We're a digital agency that likes to build next-level experiences.
Beautiful. I am Jerry Nixon, developer evangelist here in Colorado. I say here in Colorado.
You're not in Colorado.
But I'm in Colorado.
Not in Colorado anymore, Toto.
As are you. And so here's where we are. We're in a three-part small course with 3 modules. And we're going to be talking about custom panels, building your own when the ones out of the box simply are not enough. That's right. And if you're a developer for Windows 10, you're at the right place. If you know the basics of XAML and C#, you're at the right place as well. If you've never heard of those concepts and you're here to learn, you are at the wrong place.
That is pretty self-evident. If you know some C# and not enough XAML, then you could look at the previous module.
We certainly have a lot of resources out there for developers at every level, no doubt about it. If you have some resources, if you want some resources to really dig deep where we might cover them a little perfunctorily, how about that?
Boom, boom.
Here's some of the places you can go, always dev.windows.com. But here's a nice custom panel resource for you. This is the article that really will take you directly into creating your own, which we are about to demonstrate in just the next moment or so.
Oh, gadzooks.
In fact, this next moment.
Indeed.
Custom panels. All right, so the idea of custom panels, we'll talk about the basics, and we'll step through each piece of building your own. The basics of a custom panel really are pretty simple, but, well, they're really pretty simple once you know them, right? A lot like nuclear physics.
Yeah.
But until you know it, it's going to seem a little complex. All right.
Would be illogical.
We might say, what? Oh, no.
I'm a doctor, not a physicist.
Perfect fit.
Okay.
All right. That's perfect.
So why build a custom panel?
Yeah, that's really the question. Why would you build one of these in the first place when we have so many of them out there in the wild that you could use without having to do anything custom?
Yeah, I mean, do you really need a custom panel? As you say, we've talked about briefly in the previous session the stack panels, grid panels, and various other
That's
panels.
right. What if I had these look at these, Darren. What if I had these exotic requirements that I had to make my app look like this? Could I do this out of the box?
You can. You absolutely can.
Yeah, in fact, you could do a lot more than this, which really begs the question, why in the world are we creating all this extra work?
Especially if you consider that these panels have been optimized by the platform team. You know, they're built in, they're native now as part of the WinRT platform.
Yep.
And so they're going to work as fast as it's possible for these types of controls to work.
And talk about testing, because they've been around for so long and because so many developers use them in every possible scenario, they have been tested and tested and tested.
They are robust.
So they are ready to go.
Yep.
So I'm back to it. Why in the world would I not just use what's out of the box?
Well, what about this? Could you do this out of the box?
Ah, the radial panel. This is a perfect example of a certainly not out of the box example of what we don't have as far as all the panels in the toolbox.
And so you're going to go ahead and demonstrate how to write this, yes?
Yes, so this is the entire demo is going to be building a radial control. I will not be doing that, actually. But I think it's worth saying that slightly extending the demo that we will show could build you a radial control.
Absolutely. And fundamentally, the only difference will be your layout logic.
And certainly we gave a lot of fear there about bugs and performance, but a developer is a developer, and you could write your own custom layout panel that certainly is bug-free and highly performant.
Yeah.
It's not beyond you, and it's certainly not hidden from you because you are not a Microsoft developer.
Yeah, the extensibility points are already built into the framework to allow you to do precisely that, and we're going to demo some of those in a moment.
Right. All right, so we're at its core, we're really talking about a panel. And so what is a panel? Obviously, this is a class that you will be creating that derives from panel. Seems so obvious, and it's beautiful that way. Or you could derive from one of the existing panels. So panel is as base as you can get so that you can have something inside it and it gives you all the methods that you need to rearrange them. But you might actually like some of the features that are already existing in, say, the grid. And so now I don't have to inherit from panel. I could inherit from grid and just extend it.
Exactly.
That's nice. Some of the things I will get just for inheriting, just for deriving from panel, the properties that will be inherited to me are the children property. Of course, that's important. The children property, where all my children go.
Yes.
And then also the background, the transitions, and the items host. Those are all properties that I get for free because I'm deriving from panel. Items host is interesting. What's that?
So that's in effect a flag that indicates that the control is hosting an items control or one of the data repeaters.
Yeah, that's right. Or host, I guess maybe hosted inside of. I don't know the right word to say, but that's right. If it's part of one of the repeaters, then it's going to be true. Then we also have children transitions. Of course, this is special to Windows 10. It basically means that I can leverage one of the theme transitions in Windows 10 to show all kinds of neat things, adding, moving, repositioning.
And they're also platform optimized. So they're not running in software. They're going to be accelerated by your hard card.
That's exactly right. Now, those are the properties that typically, as we say here, are unchanged. Usually, a developer doesn't extend those. You know, a child collection. I don't know why you'd go and monkey with that, but you certainly could. But what would you actually come in and change? You would override and implement two methods in particular.
Yes.
In fact, it might be easiest to say that on a typical custom panel, two methods only is probably what you're going to come in and override.
Measure override.
And a range override, both of those two. Not to be confused with overriding measure or overriding a range, which sort of sounds like we're saying it wrong, and it should have been that. But we do know what we're talking about.
Yeah, and there's strong reasons for that. Because these new controls are all built as native controls, measure and a range is actually a native implementation.
It is.
So it would be very, very hard for us to get to those from the managed side of the house, to be able to override those and so on and so forth. So instead, we've got these placeholder methods, measure override, a range override, that don't actually do anything as implemented. And so when you override them, you're actually replacing wholesale any functionality that would need to be performed there.
And also because they are natively part of it, it has access to those with accessibility of like private, so that it can set values, and we'll talk about what those set internally. Because some of these, it will be important for us to return a value and just trust that the control will take it from there.
Yes.
Which it does. Beautiful. All right, so with the first property, with that unchanged property that's worth kind of understanding, that's the children property, and so that's where all the UI elements are going to go. So a UI element is a type, obviously, that comes right before, after framework element, but before control.
Yeah.
And it's basically saying things that are visible on the screen. And I then have this iList of T, so it's iList of all these UI elements that hold all my children.
Yeah. Gives you the ability to be able to iterate through them and find out how many there are, and gives you a good idea of what's being contained within your control.
Do you think that children.count may be useful?
I believe so, especially if one wants to iterate through all of my children.
That's exactly right. Okay, here are the two methods that are going to matter to you the most. Specifically, this is the measure and a range, right? They measure override and a range override. And so they are called in order, but not concurrently. So that first comes measure, but then many other measures are being called, and then eventually you'll also get called this a range. Yeah. And so we'll talk about kind of what each of these means. In fact, let's just go ahead and do that. So in the measure phase, this is the first step of your panel. A lot of things are happening, and they're all being called from your parent. Your parent is invoking all of these things, and if you could chase up the tree, we could just simplify this scenario and say it's a page, then it's your panel, then it's your child. Right? We'll just say it that so we can talk through the pipeline of it all. And we start with the page calling your panels measure or measurable.
So that is the measure, and that's the built-in measure method. And that measure method then will call your measure override if you've implemented it.
Right. So measure will always be there, and measure override, if it's there, will be called as well. It must be virtual. Yeah, that's exactly right. All right. So your panel just had its measure called, and so that is basically saying to it, tell me how big you need to be. And a panel has no idea how big it's supposed to be until it asks all of its children and figures it out from there.
Yes.
So recursively, it will loop through all of its children, asking each of them a measure, which will then call their children.
Yeah, so if we come back to the button example that we showed in the first module, the button contained a symbol icon, contained text block that was inside a stack panel. So the button itself had a complex set of measures it needed to do to turn around and say, hey, symbol icon, how big do you need to be?
Yeah.
Hey, text, how big do you need to be? Those were within a stack panel, and the stack panel then said to the button, this is how big you need to be to display your content. The button then reports up based upon its visual elements that are unique to the button up into its containing panel.
Yeah, that's exactly right. And so now we have our children figuring out how large they want to be.
Yeah.
Not are going to be, but how much they want to be. We'd call that the desired size. Then the children return to that, the desired size. Then we do some calculation inside our panel to take all of our children into account and to figure out how big we need to be to accommodate as many of those children as possible.
And this is very much a product of your unique layout. So in the radial panel, obviously we're going to be using sines and cosines and so on and so forth to establish that. If we're doing stack panels, then height or width becomes the key deciding factor for determining how large our panel needs to be to contain all of its children.
That's right. So once we have that figured out, then we return up to our parent, which is what, the page in this example,
yes.
How big we need to be. Done. That's the measure phase. There's one more phase to come, but that's the first phase that passes through. Meanwhile, it's good to recognize there are other perhaps sibling panels that we have, other things. The page has to call all of its children, not just the first one, and so other things may happen. That's the reason they're not back-to-back. Measure, arrange. It's measure, wait for everybody to be measured, now arrange. And then we could talk about arrange. Anything else in measure we need to figure out real quick?
The only main thing was we don't need to call the base measure override.
Ah, that's right, because it's just sitting there waiting to be overridden.
Yep.
All right.
Apparently, it has not native implementation.
It has. That's exactly right. That's not. That is not native.
Not native English, I'm sure. Okay, so let's have a look at this example of
I'm really glad you pointed that out.
the panel measure override. So, what's going on here, Jerry?
So this is the simplest measure override. This is setting up a stack panel, and this is just all you need to do. So the first line you can see, we're just keeping track of height, and we're going to continue to append to that, making it a little bit larger and larger, or increment into that. And so then we have a for loop where we're looping through all of our children, and looping through all the children, their framework elements in this case, and we call their measure. And so this is me passing in available size, which you can see is also passed into this overall
So we're saying
method.
as much space as we have.
Look, this is how much space we have. Given that, how much space do you need? And then that next line is all we're doing is keeping track of that height, so it kind of increments.
So here's the key thing. Desired size is only set after we call measure.
That's right. If I had tried to increment height prior to calling measure, it would be not a number.
Yep.
That's exactly right. Only after calling a child's measure does that get set. Then the final is I return the not the combination.
Aggregate.
The aggregate, yeah, thank you, of all my children's height, and then I'm going to stay at my width because I'm just a stack panel. And so there it is. That's a simple measure override.
Yep, cool.
Yeah. Phase 2.
Phase 2. So,
the arrange phase is the next phase, and the arrange phase is when the parent is saying to the container, this is how much size you really have.
Yes.
And it's not really asking a question anymore. It's saying, given all of my constraints, I'm just going to let you know how much space you have now. In fact, the panel then carries forward and gives that to all the children as well.
So if we just think about for a second, where are those constraints coming from? In the previous module, we talked about, say, a grid panel, where you could have star sizing or auto size and so on and so forth. So the available space for any given cell, perhaps in a grid, is going to be a product of all the sizes of all of the others. There's actually a specific order that a grid evaluates all of its various size precedents and orders to determine what cells get allocated what space. But ultimately, that's where your constraints are going to come from. Things that are influenced and inherited by the panel by virtue of where it's placed, the device you're on, and so on and so forth are all going to give you size constraints.
It's worth remembering that there's no UI to a panel. The only UI a panel really has are its children UI. And so calling arrange to a panel doesn't cause it to render. It causes it to invoke its children to render. And so when arrange is called into a panel, obviously that's actually calling the arrange override where we implement all of our logic. It then loops through all of its children, passing in what its constraints are, causing it then to render and causing the population of actual size. Is that right?
Actual size is basically after the child arrange has completed.
That's right.
Then actual size contains, funnily enough, its actual size.
Yeah.
It's also available for consumption in the layout updated event.
There is some logic to consider that even though you're telling your child in the early measure phase, you're like, how much space do you need? It doesn't really mean it's going to get that space. And so here in the arrange, you said, remember when I asked all that space you needed? I'm sorry, you really only get this much space. And passing that into the range of the child control causes the logic in the child control to handle that constraint. And so it's not up to me as a panel to figure out how the children are going to, wrap their text or whatever. That's all up to the individual child controls. I'm just passing in those numbers so that they can do it on their own. That's really nice because it simplifies my logic and it also separates the logic, so I don't have to handle
makes sense. A control needs to be responsible for rendering itself. It knows itself best, after all. And so it's a nice separation of concerns.
If I do pass in too small of a space, though, for a control, and a control, let's just pretend a control says I can't be smaller than 100. I pass in 80. What's going to happen there? It has to go to 100 because it can't be smaller than 100. It was serious. So it goes ahead and renders to 100, and 20 pixels are clipped, height, width, or whatever that might be.
Yep.
Yeah, they'll just clip away. But that's the way it has to be, and then you as a developer / designer get to figure out how you kind of take care of that so it still looks nice.
That's why testing is so important.
Yep, this base method of arrange override, base.arrange override is still empty and virtual, just like in a measure.
Yep.
Perfect. All right, so this is a simple implementation of what it might look like to have your own arrange. This is the continuation of a stack panel and what it might do. Obviously, a real stack panel will be a little more sophisticated, but this actually gets it done. All right, so remember, measure has already been called, and so now arrange is being called, passing in its final size. So this is a true constraint, not a question. And so we keep track of height because we're going to increment that as well. And so we loop through all of our children, and as we go through each of the children, we call their arrange. And so calling the arrange of each child, we pass in a rect, not a height and width, but a rect, or it's a struct, right?
It's a struct,
that includes both the size as well as the starting point. So this is us saying to the child, passing in both its size and its where to render.
Yes.
Like here.
Position, relative.
That's right. And the underlying framework then knows how to read that and then draw in that constraining box. That's the rect there. Very nice. Obviously here, then we go ahead and keep track of the height. And when we return, what we're returning is, this is a typo. I mean, I just want, I'm going to make a little note here that you don't do it this way. Yep. You return a new size of the final width and height. Of course, in the code sample that we have, this is all correct, but this slide is obviously right before we fixed it. Right? Don't call base.arrange override. This is just an example of what you're not supposed to do. We just want to make sure you got that really clear. All right, great.
A rescue attempt would be illogical.
Oh my gosh. All right. Now, that's the basics of how you might put one together.
Yeah.
And now I think it's
Now you've shown how to do it wrong. Why don't you show how to do it right?
Yeah, right. Now, stay on script, because this is what we had planned the whole time. All right, a custom panel demo. I think that calls for Visual Studio. All right, so let me jump over to Visual Studio. I already have this loaded, but let me just kind of show the structure of this project so it makes sense. There's only 2 files. This is just the blank project, and it has the main page, which is what you would expect. But it has this nice little control folder with a new class in it called My Stack Panel that if I were to go ahead and collapse this so you could see it, is called My Stack Panel. And just like we said, we inherit from panel, the end, right? That's pretty great. And so here we have our measure override, and we also have our arrange override, and let's see how we implement each of those. So this logic is going to be the same as what we showed in the slide, right? So we keep track of height, loop through them all, calling measure, and then finally returning the aggregate of height. Okay. That's the end, right? Pretty nice. As a reminder, calling child.measure is important in order to get desired size in the first place.
Yes.
It's not a value until you
And then
call it.
ultimately we're returning the desired size for the overall panel at the bottom.
That's right. Accepting the width they gave us, but giving them potentially a shorter height. Yeah.
Yep.
All right. And then let's take a look at arrange. So arrange override does basically the same thing, right? We're going to loop through all of our children, calling arrange, giving them a specific size. In this case, we'll take the height that they provide us, and then give them the desired size as well. All right. So from there, we will, from there we'll return the final size. Yeah. Because we'll just take what they gave us. Yes. We're not making any changes. We're just trying to fit all the children into the place. All right. So if I were to run this, right? If I were to run this. Right like that.
Quick as a flash.
quick as a flash. So right now, what it's doing
is showing everything on top of each other.
Yeah, so this is showing everything on top of each other. And why is that? Because of this line right here. In fact, let me go ahead and close the app here. Because of this line right here. So I'm passing in a rect, and you'll remember this is the size that it wants to be. I'm passing in back its desired size because I'm just letting that stay the same. But I'm putting it at 0, and then it's child.height. Right? That's accomplishing nothing.
Yes.
Everything is being set basically at the exact same location, so you're just sitting on top of each other. So let me first remove this implementation and show you what we have here as far as the stack panel itself. Right? So this logic, take that off. Holding down Alt, by the way, to do that. People always wonder how you do that in a demo. And so here now we keep track of the height, and you can see here height is actually being incremented, and we have a little check here to say if the height is actually higher than the size we were finally given, which is a possibility, then we're going to break out of this and not even draw that child.
So it's great for efficiency.
It really is, because let's say we have room for 10 children, but we actually have defined 5 million children. Right, that's a serious efficiency gain.
Yes. Will be significant.
All right, so no change, but no change there. I'll go ahead and run.
I'm giving a loss this door, Captain!
Hold on. All right, now it's doing it the way you would expect because height keeps going up with every item in it. Beautiful. All right, here's another fun thing. So one thing we know is the size of the individual item. So let's look at the XAML and how that's laid out. So here are our 4 items. We get this nice design time experience. That's pleasant.
Yep.
And so here is my my stack panel, and I have these 4 rectangles in there, and you can see I've got one in the middle that I currently have commented on.
Okay, so what we can see straight away is the syntax for using your custom panel is virtually identical to using any of the other panels. And
That's
so
right.
That's the benefit we get from inheriting from panel. We don't have to come up with any other sort of paradigm for how you use it, set properties, and so on and so forth in exactly the same way.
Yeah, that's right. So each of those had a width and height of 100, which made it very easy to draw them. We knew their size. But now we've got this third one, and I'll go ahead and uncomment that. And so you can see its height is still set to 100, but it doesn't have a width property set. What it does have, however, is the horizontal alignment stretch that we talked about in the previous
So why isn't it
session.
stretching?
Well, there's a couple reasons why it's not stretching. The first one is I'm not quite sure. No, seriously, I have no idea yet. No, I'm only kidding. So the reason it's not stretching is it's going to take some logic now to be able to determine whether or not what the width should be.
So the panel has to know what size it's going to be.
It really is.
Influence this.
Almost this property here says I'll leave it up to my parent in a lot of ways. So now let's go back to our stack panel, right? And this is all going to be handled up in measure. And so we'll go down to measure, and let me take this implementation out and just expand this one, right? So get rid of these little regions. They were nifty, but not what I want. And then I'll just delete this, holding down Alt.
Still.
People always wonder. All right, so like before, I'm looping through all my children, but I'm doing one special thing. I'm casting it now to a framework element. Of course, I know that will work because I'm really only accepting framework elements. But if it's not null, just being double checked, right? And what about the width property of this element that I just created, or I just cast? What's its value? Is it not a number? Pulling it in from, because I know it's a double. If it is not a number, which is kind of like that null sort of feel to it, right? If it is invalid, then we know that that is auto, which is basically saying, please set it for me, right? Just depending on what the appropriate size. And then I'll just check one more thing. Well, if you're going to go ahead and not set width, so leaving it unset, but also you're going to set the horizontal alignment to stretch, which I'll just remind you by jumping back that that's exactly what we did. We didn't set width, and we set horizontal alignment to stretch. Well, in that case, you'd be right here, and you would say the width should be the width of available size. That's the available size of the parent. Now it's as wide as possible because the parent itself has a width. Then, of course, we call measure just like any other. And if none of that is true, it's still a child, and we still need to treat it like that. And so we say child.measure anyway, passing in the same logic as we had in the previous.
Great.
So the only difference is this little extra of horizontal alignment so that we can manually set the width, still keeping track of the height the same, and then returning the same way as well.
Okay.
So now if I don't even need to run it, to be honest. I can go back here. Of course, we just changed the code, so let me build it real quick. And you can see the design time experience is going to take, what do you think of that? I think it's the logic. It was too complex.
I think
know.
I think
Let's
you've
give it
overloaded
another
it.
chance. Come on. I'm petting Visual Studio to give it a shot.
A rescue attempt would be illogical.
Yeah, there's never too much noise. So here we are with the, here we are, you can see it. This is the yellow one. You can see I colored it yellow. And you see it's as wide as the item is here. And in fact, you can see it's even clipped here because there's going to be something to do with the grid that's caused that to happen.
It's probably because it's constrained, yeah.
Yep.
Absolutely.
And so I'll go ahead and run it just to prove this sort of thing can work. Very nice. Just the way you would want it. And there's the...
You got a width on your stat panel, which is why it wasn't going.
There's the width of 300 that you
Yeah.
want. That's exactly right. All right. One more thing I thought you might be interested in seeing.
Do
I have
tell.
this button here, and so I will uncomment the button. I've got a little add item up here.
Mm-hmm.
And this is a fun little thing we'll have in all of our demos here in just a sec. And one of the properties we get for free, we talked about it in a slide, but I want to just show you, is this idea of children transitions. So a transition is a theme object that comes for free from the platform, and I can build custom ones as well, that allows me to apply to each child, and it has its own kind of cause, right? So this one is when it is repositioned, then something new happens, right? And so a repositioned item, well, if I added an item, let's say above red, that would push all the others down and they would be repositioned.
Okay.
And so it would run the reposition. There are many others. In fact, if I were just to do this for you real quick, there are several others, including things like add and delete, and keep on going. Entrance UI, Edge UI, if it's sliding in, I would use these for other types of controls.
Lots of
not
flexibility
necessarily
there.
this. Right, exactly. Popping up, reordering, things like that. All right, so let me
So
move
what does
that.
it do?
Well, let's just take a look at what it does. The button's already implemented here. I have the code behind just to insert a new something.
Okay.
All right, so I click this. Ah, very nice. You see them all kind of jump down in a little
kind of float
gamey
down.
way. Yeah, here, I'll do it again. Yeah, it's really, really nice.
And of course, you didn't have to do anything special to your stat panel to get that.
Because I inherited from panel, I already get the native functionality that I would want to have. It also makes my panel usable by other developers because they know how panels work. So if they know how a general panel works, they know how mine works. It just looks correct for the special case or the special, what was the word we were going to shoot for? Special.
Signature experience.
For the special signature experience. That's right. This is really fun to watch, but you can do this to it too. You can click like super fast, and then they can't keep up with each other.
And unfortunately, they're not looking at your screen.
Oh, it's too bad. I just want to throw out the name Danny, the best possible producer. Well, that was the only chance you get. All right. Just know if you click the button really fast, it's not the experience you want to have. So.
Okay, so let's change over to my machine and look through something that's a little less trivial in terms of implementation.
Yeah, stack panel's simple, plus we already have one.
So first of all, let's run this one and show the outcome. So here we have a column panel that we've built. And you imagine the scenarios here that imagine you had some interests and some things that you felt like you should pin somewhere. Then you might have seen a UI similar to this.
My wife has talked to me about things like this.
Oh, yeah. Interests that you would pin?
She has very many interests that she pins.
So the idea behind this is that content is laid out, moving across the page until it can't fit anymore. And then additional content is added into the shortest column.
Ah, so you're just filling space. It's not a matter of being in order, it's a matter of filling as much space.
And so as we scroll down, we get lots of different panels that are laid out approximately in the same size.
Now, this is worth pointing out. There is no control that's out of the box in your XAML toolbox that will do anything like this.
Correct.
This is truly a scenario that you would need a custom solution.
And so what we've done here is we've used element binding, which we'll cover in more detail later on. But this slider will actually control the width of the columns in here. So if I change the column width, you can see that these things animate and lay out appropriately based upon the column width, which is very interesting. And we've got some great animations, which again come as part of the platform.
Yeah, it looks like you have a similar type of theme animation that we were showing off with Stack Panel.
Yep.
And I don't mind saying that as you were rearranging it, it was actually remeasuring everything and making sure that it fit properly. And sometimes it needed to rearrange the way that the individual children were, which column they even belonged
push them into different
They
columns.
weren't getting more narrow, they were really being arranged properly.
Yeah. And also, you demonstrated add items, so we can do that here. So if I add things in, you can see We get different entrance animations here, and you can see how everything lays out again as we add in new elements. And so you can see how it moves across the page and drops down and so on and so forth.
And only because these children are all uniform does it look like a uniform grid. It's
Yep.
just nice it also has the logic to handle if it starts becoming taller.
Absolutely. So let's talk about the logic a little bit.
Yeah.
So we're going to jump across. Firstly, let's take a look at the XAML just to see how this is laid out. So we have our elements. So we've got a custom control column panel here. We have a series of stack panels that are contained within it, and these are styled using a style, and we'll be covering styles in a later module.
And you're not expanding those only because they're just holding content so that we can see something.
Exactly. You know, there's a lot of content there, and it would be obscure
Right.
the reality of what's going on here.
I can see your children transition is set up. Beautiful.
And so we also have, here's the slider, and we have the slider name, and we're using this binding syntax here to attach the column width property of our column panel to the value of our slider. And so that's how we're dragging that around.
That makes sense, and I see. And so mode one way, so it's always listening for slider to change, and
Yep.
it updates. Now, column width, that's a property you created?
That's a custom property we created on our column panel. So let's take a look at the column panel. So here's the column panel.
Oh, that seems so simple.
We've inherited from panel, as all good panels should, and we've created a new dependency property. So quick segue and talk about dependency properties.
Ah, good. A little XAML candy here.
Exactly. So these are a special type of property that's really unique to XAML that exposes up properties that can be set during design time, during animations, and so on and so forth. And they're very interesting because they're declared statically. And there are a number of different properties within the dependency property definition that we supply. For example, here we're turning around and providing a shorthand name for the dependency property. We're using the new C# name of property to turn around and say we don't have to have a magic string for column width.
Right, don't want a literal string.
Yep, so that's basically just at compile time injecting a string of column width in place of these tokens.
So what you're highlighting, the dependency property, is its companion is the property getter and setter below it.
Correct. And these are using a special syntax, get value and set value, to be able to inject the values into the dependency property via this more regular .NET related property accessor.
And to be clear, this is very similar to the attached property that we were showing in the previous module, so you could add something to a class without having to extend it.
Correct.
That's not what this is. This, although similar and
Yes.
also static, is intended to be part of the class and
Absolutely.
to make it exposed in a way that things like the animation framework underneath, the storyboards can write to it very, very easily, as well as the data binding underlying framework can write to very easily as well without having to know too much about it.
Yeah. So just to come back quickly, what we've done is define the type of our dependency property, which is a double. We've said it belongs to column panel, to your point.
Yep, that
make it
just
available
locked
there.
it in.
This is a particular syntax that allows us to define the default value for our dependency property, and also an action that is going to be invoked whenever the value changes of our dependency property. And so what we're doing here, and we haven't mentioned this, but invalidate measure causes the measure and arrange cycle to be repeated. So what we're saying is, if we change our column width, then we wish to invalidate and redraw our column panel, which is how, as I move the slider, we redraw our panel.
And unlike the regular measure method, nothing is getting passed into this. So when you do it, you're basically saying, based on the previous parent passing in its final size, do it again.
Yes.
Yeah, so you're not resizing the panel, you're resizing all of its children.
Yes. Okay, so let's have a quick look at the measure override, because obviously a little bit more complexity going on here than just stacking something vertically. So we've got a bit of an algorithm here, but again, it's not particularly expansive.
No.
We are determining what our column count is by turning around and saying, looking at our available width and dividing it by the size of our columns. Then we're using math.floor to round down.
Yep.
So we make sure we get whole values in there.
So because you don't want half a column.
Yeah. Now we're creating an array that is going to contain the size of each of the columns we have within our control. Because bear in mind, we're trying to track which column has the most room in it, so we add our next control into the shortest column.
Yeah, that's right.
So this is the array that tracks each column's height. Common to most panels, you're going to loop through each of your children. We are now going to look up and find the column index that is the shortest. If we imagine we're starting from empty, then the first one that it finds is going to be the shortest column. We're then saying to the child, measure yourself based upon the constraints of the column width and the available height from our control. So the only real constraint we're supplying is you cannot be wider than the column width. We then get our desired size, and we then apply the desired size height to our column index.
Keeping an aggregate so you can keep track of just
Exactly.
how high or what's the height of each column.
Exactly. So we loop through all of that, and then we ultimately return a size for our panel, which is based upon the available width that we had right at the outset, but the height of our tallest column.
Very good. I think that makes sense.
So that's basically our measure. Now, as we mentioned before, that's all great, that's advisory, and that tells the parent of the panel, this is how much size I need to have to show everything based upon my assumptions. Then we get the arrange override invoked, where our parent turns around and says, well, that was all very nice, but this is the size you're going to have.
This is the serious method.
Yeah. Now, in most cases, you're probably going to get the size that you asked for, which is a reality, especially if you're building a top-level panel.
Yes.
It's highly likely that that's what you're going to get. So here, we again repeat the similar algorithm. We
Zoom in just a little bit for me.
So we're in our similar algorithm. Easy for me to see.
There's a gorilla.
Algae gorilla.
There's a gorilla?
There's an algae gorilla. Goodness. If Danny was on the ball now, we'd have a gorilla jumping on my shoulders. So we are
But there's no risk of that.
None whatsoever. In fact, he just woke up. What? So.
He's laughing extra loud now.
Indeed.
I'm awake!
He's awake, apparently. So we've got our column width, and we create our new array of column heights, because remember, we don't care about what we developed during our measure at this point. We're now going to go through and say, okay, this is what we did in reality, our actual heights. Iterate through our children again. Once again, we turn around and establish which column index we're inserting into. We create a new rectangle. Now, the interesting thing here is...
This is a struct rect, so different than a rectangle.
Very correct. So we're creating something that has an anchor point. So we're taking our width multiplied by our column index. That's going to move us across in our X position for our column. We're going to take the column height, column index. So we're taking the bottom position of the column in which we're inserting and using that as the starting point for our new element.
Right, because that X and Y that you just built out there is really saying start rendering here.
Correct.
Yes.
And then we're actually going to use the child's desired size and say this is the size that you're actually going to render.
Very nice.
So we then tell the child, you will arrange yourself within these bounds.
Perfect. And that is the go button, basically.
Exactly. Now, if we also remember the thing about arrange, that's when the child's actual height gets set. Now, because we're actually passing in the desired size as the size that we wish it to draw to, desired size and actual size are the same.
It's almost a guarantee because desired size is what it asked for, and we're giving it what it asked for.
Exactly.
And in this case, if it happens to be the final size is smaller than what we did in measure, then the items will be clipped.
Yep.
Right? But we know our use case here, so we don't have to have extra logic.
Okay. And then basically we return back our total size. So if we come back and just run the app again.
I'll just give a quick shout out to Sean Kindrad, who sort of inspired this.
Absolutely. He had a great working example of this, and we kind of added some different behaviors.
Yeah.
So again, here is our size. As we change the dimensions, we can see how this lays out differently.
That's right.
And again,
nice.
As we change our widths, we can see how these lay out.
Now, the logic that you have inside a panel is important so that it lays out properly. But the more aggressive that logic is, the more items you have in that panel. Those things are orthogonal, of course, and then soon you start really impacting the performance of your panel. So you might think, well, there's 1,000 small edge cases I want to make sure I take care of, just in case my control is used like this. But if it's not likely that your control will be used like that, you can really save yourself a little bit of headache because every drop of logic that you add is multiplied by the number of items inside your panel.
And ultimately, performance is key.
Ultimately, user experience is highly valued by users.
Yeah. And their experience.
I'm tired of users.
Yes.
So true. All right.
Okay.
Anything else in that demo you want to show us?
No, I think that covered it.
Pretty awesome, honestly. It's pretty amazing. I mean, if you boil it all down, it's like 50 lines of code.
Yeah.
I mean, for what it does. And I think, the average developer out there starting with XAML is like, man, someday maybe I'll even build my own layout control. But little do they know how straightforward it really can be. You just have to keep a clear mind and a focused eye while you're building it, and then all of a sudden it's there. It's
Okay.
really, really nice.
So let's quickly summarize what we covered. We talked about custom panel basics. We really talked about the workflow for determining the size and arranging your children.
Yep.
And gave a pretty good demo, I think, in terms of building a simple stack panel.
Yeah, just feeling out what about the basics? How does a stack panel work under the hood? Now we've got at least a clue for it. And then what if you want to do something special, something that is very unique, have that signature experience for the application that you might be building? What extra work is it going to go into? Now you get to see kind of and feel under the hood what is actually going on, and it's not that big of a deal.
Yeah,
So,
nothing to be scared of.
should you build a custom layout control then?
Only if you need to.
Yeah, that's really right. Be sure you're familiar with the ones that are in your toolbox. There's a lot you can already do. It doesn't mean you shouldn't build one if it's identical, but you got to think that through if you're going to be doing it, because the ones that are there are nice.
They're good.
Yeah. All right. That's part 2 of this 3-part module course, 3-module course, I guess. Yeah, and so we talked about the basics of these layout controls and those fundamentals. We just talked about building a custom one. And in the next module, we'll be talking about
Effective layouts.
the effective layout. That's actually going to be a lot of fun.
It will be.
Yeah, so that's going to be some of the architectural approaches you'll have and how you can do those. And we'll see you there.